So in this scenario, we're going to be talking about people with bald and no hair at all, non-balding. So the baldness codes for recessive, which is little b, and then non-balding is coded by big B, little b, or big B, big B. So 360 of them are homozygous recessive, 480 of them are heterozygous, and 160 of them are homozygous dominant. So we have a total population of 1,000. So we're going to do the phenotypic ratio, which we're going to do baldness over non-balding. The homozygous recessive are the ones that are bald, and these two are not. So what we're going to do is 360 over 640, because 480 plus 160 is 640. And so we're going to come up with a ratio of 360 to 640. And that is going to be A, the phenotypic ratio. The frequency of alleles, which is big B and little b, can be calculated with the formula P plus Q. So first, we need to find Q, which is 360. So what we're going to do is do 360 out of 1,000, and that's going to give you 0.36. From 0.36, we know that this is Q squared. So we're going to square root on both sides. Q is equal to 0.6. We use P plus Q equals to 1. We're going to plug it in. So P plus 0.6 equals to 1. Subtract both on both sides. And P equals to 0.4. So now we have P and Q, which are the frequency for the alleles big B and little b. Now that we have P and Q, we can find out the heterozygous individuals by plugging it into 2PQ. So 2 times 0.4 times 0.6 is going to give you 0.48. And so 0.6 will obviously be the homozygous recessive. The 0.4 will stand for the homozygous dominant, and then the 0.48 will stand for the heterozygous individuals, 2PQ. Well, Q squared will calculate for the homozygous recessive, and P squared will calculate for the homozygous dominant. So
wait, no, I need to know the exact question. That's right.
We're gonna square it. And then that's fine. Okay. So
so here we have
P
another question.
squared, we're gonna get 0.16.
Now, in this scenario, we're going to be examining
Q
the T allele and
squared.
the ability to taste BTC.
We're going to get 0.36.
Now, we've already given
So
in advance
this
some
value
ratios. We know that
is
we
going
have
to stand for the homozygous recessive, and this value will stand for the homozygous dominant, because we're referring obviously to this formula.
T lower T. Because T having the double
Which one represents for the 100% of the population.
Now, on the contrary,
Those are the frequencies.
65 out of 25 could not, which means that